number 4, we are dropping some XYZ into some water. 2 different substances that start at 2 different temperatures. This is like our lab where we took the warmed up piece of metal and dropped it in the room temperature water. 2 different substances, 2 different temperatures. There's no reaction happening here, but what's happening is that the heat lost by the hotter object is going to equal the heat gained by the cooler object. Heat lost, heat gained is going to allow us to solve for whatever we need to. For Q, generally being MCP delta T for each. For XYZ, we're dealing with a mass of 70. The CP, now we have XYZ at 79 degrees. According to my chart, or the given information, it's a liquid at that temperature. We're below the boiling point, above the melting point. So the CP would be 1.2. I'm going to leave change in temperature blank for now. The water, MCP delta T, is also going to change temperature. 50 grams of it, CP is 4.18, and it will change temperature. Now, intuitively, we know that the hotter object is going to cool down, and the cooler object is going to warm up. How I have always solved these, when it's heat lost equals heat gained, that's when I like to incorporate a thermometer where the hotter object cools down to some final temperature. What we're looking for is the final temperature. I call it X. So what I am calling X in this problem will be final temp. The cooler object, water, is going to warm up to that same final temperature. Final temperature is the same whether asked about for XYZ or for water. They stop at the same final temperature. Then, for XYZ, those are the 2 numbers associated with it. Its initial and its final. Bigger minus smaller. For water, that's its final and its initial. But I still do bigger minus smaller. The way I've always taught these problems, I'm never doing any pluses. It's always something minus something. Bigger minus smaller. This setup is correct and would get you like 2 of the 3 points for this problem. From here it's algebra, so just show steps, go slowly. 70 times 1.2, 84. Distributing the 84. Sorry, not all of this is showing up. Distributing the 50 on the other side. We get 209x minus 2090. I'm going to change the colors here. Maybe just markers. Adding the 84x to the 209x gets me 293x on this side. Adding the 2090 to the 6636 gets me 8726. Divide both by 293. Gets me x by itself to be 29.78. Because x is what I decided to call my final temperature, I have my final temperature, and I'm done.